Okay, this is the homework for tonight, Thursday the 17th. So the date is not right on the paper if they didn't already change it. We have been working on fractions on the number line, and I know that this is a very big concept and something that as parents and adults we probably have not visited in a long time. So we just wanted to kind of give you a quick tutorial of the problems. We've been working on this for several days in class. The students have said they feel pretty good about it. You should see their classwork, hopefully, that they've done. If you need something to refer back to, but that's why we wanted to give you the video as well. We also sent out a link to a learnzillion.com video that also kind of explains fractions on a number line. So that way you have multiple resources to use to help you understand if you need it. So on A, it's all done for you. So that's another good example to look through. So basically, all these fractions that are boxed are only boxed just because it's showing that it represents one whole on the number line. So 3/3 equals 1, and that's when your numerator and denominator are the same. That equals 1. And we look at it like 3 divided by 3 is 1, or 1 times 3 equals 3, which is your numerator at the top. Okay, and same thing here. 3 times 2 is 6, or 6 divided by 3 is 2. So 6/3, that's called an improper fraction, is the same thing as 2. And last is 3 times 3 is 9, or 9 divided by 3 is 3. And so 9/3 could also represent 3 wholes. And the best way that I kind of try to explain this is that 3 wholes could be like 3 whole brownies. You got 1 brownie, 2 brownies, and 3 brownies. And the improper fraction was 9/3. So everything on that number line is split into thirds. So that's just like if I went and cut each of these 3 brownies in 3 pieces or thirds. And what I'm doing here when I'm drawing 2 lines, we talk about that little trick. If you want 3 equal parts, then you only have to draw 2 lines to get that. All right, so now I took 3 whole brownies. Okay, so that's where my hole is. I split them into thirds. Each one is split in thirds. And if you look, I actually have now 9 pieces of brownie, even though I started out with 3 whole brownies. So like if I ate this piece, I got the 7th piece of the 9 pieces of brownie, but the 7th I got from a brownie that was cut into thirds. So that would be 7/3 on the number line. If I ate this piece, I got the 4th slice of brownie, and the one I got it from was cut into thirds. So that would be 4/3. So that's just kind of to show you how improper fraction can represent a whole. So here they just took the numerator and they just jumped every time. 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3. So on this one, it says eighths. Okay, that means this hole needs to be split in eighths. Now we only have 1 hole on this line because we're just going from 2 to 3. Here we went 1 to 2 and then 2 to 3. We only have 1 hole to split up this time into 8. So we're splitting in eighths. We only need to draw 7 lines. 7, and then I always make them count. Do you really have eighths? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if we're splitting it in eighths, that means every single denominator is going to be 8. So for the wholes, 2 times 8 will get you to 16. So this will be 16 eighths is the same thing as 2. And this one, 8 times 3 is 24. 24 divided by 8 is 3. So 24 eighths is the same thing as 3. And then here they're just jumping. 17, 18, 19, 20, 21, 22, 23, 24. These are just boxed in because they are improper fractions that represent a whole. So this one is fourths. So every whole, which we have 2 on this line, needs to be cut into fourths. So if I want 4, I only have to draw 3. It's a little one less trick that they know. So I split those into fourths. Check it to count. 1, 2, 3, 4. So this one is in fourths. And 1, 2, 3, 4. This one is in fourths. Okay, and we're doing 4, so every denominator is going to be 4. And then we got wholes 2, 3, and 4. So 2 times 4 is 8, or 8 divided by 4 is 2. So 8 fourths is the same as 2 wholes. Okay, then you just jump. 9 fourths, 10 fourths, 11 fourths, 12 fourths, and look right there. 4 times 3, 3 times 4 is 12. 13, 14, 15, 16, and again, 4 times 4 is 16. 16 divided by 4 is 4. And for the last one, we have halves, so that's 2 equal parts. So this whole needs to be 2 equal parts, and this whole. If I need 2, I only draw 1 down the middle. It's halves, so every denominator is 2. Okay, 3 times 2 is 6. So 6 halves is the same as 3. Just keep jumping. 7 halves, 8 halves, and it checks out because 4 times 2 is 8. 9 halves and 10 halves, and this one checks out because 5 times 2 is 10.